Rational expressions, this time we're going to be talking about what we call complex fractions. Just so you know, a complex fraction is anytime you have a fraction that's involved in another fraction. And when I say involved with, it means division. For example, 2/3 over 5. That is an example of a complex fraction because we have a fraction in the numerator of another fraction. Let's take 4 over, let's say, 2/7. Because we have a fraction in the denominator, this is also considered a complex fraction. How about 1/2 over 4/5? Because we have a fraction in the numerator and or denominator, this is also a complex fraction. So complex fractions are fractions that have fractions either in the numerator, denominator, or both numerator and denominator of another fraction. So let's go ahead and take a look at simplifying complex fractions. So here we have example 1. We have this numerator that consists of fractions being added together and a denominator which has another subtraction of fractions in it. So the main fraction bar is here. So what we want to do is simplify the top, simplify the bottom, and then take care of simplifying the expression. Let's see how to do that. Well, we're trying to add fractions on the top, so we have 3/4. To be able to add or subtract fractions, we have to have a common denominator. So the common denominator of 4 and 2 is going to be 4. So we have to rewrite 1/2 as a fraction with 4 as the denominator. So 2 divides into 4 twice. 2 times 1 is 2. So let's write that 4 again. Like that. There we go. All right, what about the denominator? The LCD of 6 and 3 is actually 6, so the first fraction is good. We're going to leave it alone. So now we need to write 2/3, rewrite that so it has a denominator of a 6. 3 divides into 6 twice, 2 times the numerator 2, which is now 4. All right, so now we can simplify the top. We have on top 3/4 plus 2/4. When you're adding fractions, you keep the common denominator and you add the numerators. That gives us 5. For the denominator, we have 5/6 minus 4/6. That leaves us with 1/6. Once again, we keep the common denominator and subtract the numerators. So remember, a fraction bar means division. So 5/4 divided by 1/6, it means 5/4 divided by 1/6. So in other words, this fraction bar here just really means division. So we just rewrote it like this. This is where we keep, change, flip. That's how you divide fractions. You keep the first fraction, you change your division to multiplication, and then you flip the second fraction. When we multiply, we're allowed to cross cancel. That makes the math maybe a little bit easier. So 2 goes into 4 twice. 2 divides into 6 3 times. So we're left on top with 5 times 3, which is 15. On the bottom, 2 times 1, which is 2. So 15 halves, or if you write that as a fraction or as a mixed number, that's 7 1/2. Keep in mind that 15 over 2 is a reduced fraction. That answer is okay as an answer. If you change it to 7 1/2, that is merely converting it to a mixed number. All right, let's take a look at one last example. All right, so here in example 2, we have a fraction and then we're subtracting a complex fraction from it. So what we need to do first is simplify the complex fraction. And here we have, in the numerator, we have a minus minus. We're going to change that to a plus. And then in the denominator, we have a plus minus. We're going to change that to a minus. So let's just go ahead and rewrite the problem. We have 4 over 11. Minus, on top we have 2/5. Remember, a minus minus becomes a plus. Then we have 3/10, and that's all over 4/5 minus 1/4. So to simplify the numerator portion, let's go ahead and write this going downward, I guess. We have 4/11, and then we're going to subtract from that. The common denominator of 5 and 10 is 10, so we just want to rewrite the numerator expression like this. The second fraction already has the 10, so it has the LCD already. So 5 divides into 10 twice. Twice the 2 makes 4. So we just simply rewrote the first fraction of the numerator with an LCD of 10. Likewise, the common denominator of 5 and 4 in the denominator is 20. So we're looking here at the LCD of 5 and 4. Again, that's 20. So 5 goes into 24 times. The other 4 makes 16. 4 divides into 25 times the 1, which is 5. Let's scroll down a little bit. Now we can add the numerators that we have here. So here's what we're doing now. We're taking care of the addition of the numerators. So we have 4 elevenths. On top, 4 tenths plus 3 tenths is 7 tenths. Let's write that fraction bar again. And then in the denominator, we have 16 twentieths, and we're subtracting 5 twentieths. So that leaves us with, it looks like, 11 over 20. Then we have 4 elevenths minus, remember with a complex fraction we keep the top fraction. This fraction bar here means division. So we're dividing that by 11 over 20. So this is where we keep it as the 7 tenths. We change our division to multiplication and we flip the second fraction. And now we can cross cancel. Looks like we have here the 10 and the 20. 10 divides into 10 once, into 20 twice. So we have 4 elevenths minus, on the top we have 7 times 2, which is 14. On the bottom we have 1 times 11 is 11. So it works out this time we already have a common denominator to finish the problem out. We have 4 elevenths minus 14 elevenths. We subtract the numerators. We keep the denominator, and that looks like negative 10 elevenths. So what I'm going to do is just verify this on the calculator. So let me go get that typed in. I'll be right back. And as you can see, that did give me the same answer. There it is. And I can scroll up just to kind of show you that I was able to type in the problem as I saw it on my paper. I did change the double signs here, but once I typed it in, I pressed the enter button, and it again gave me my answer, which is negative 10 elevenths. And that's what we got as our answer right there, negative 10 elevenths. So it checks out. We are good on that problem. So anyway, I hope this helps you understand complex fractions and how to simplify them.